Bismillah, Assalamualaikum warahmatullahi wabarakatuh. So this is just a refresh on two basic things. I will focus on one in trigonometry and second in integration. These two things you have learned already in CFS in your foundation study, and even some of these you have learned also in your secondary school. But interestingly, I found that in the previous semesters many students still struggle to apply this into what we are learning, which is in the mechanics statics. So the purpose here is for me to bring you together to refresh on this and refresh specifically how it normally will be applied in what we learn in mechanics statics. So that's the purpose today. I'll divide this video into two parts. I think I will tackle trigonometry part first, and then also the integration part, right? So I'll cut it so that if you do not need to watch for the trigonometry, you can go straight for the integration part, inshallah. Alright, so but make sure that you understand how to apply. If you understand this already, then this video is okay. If you do not even want to watch it, but if you have any problem, make sure to refresh, and we will not go into detail to reteach you. Alright, because you have learned this already, we just refresh a bit the concept and straightway discuss how it normally applied in our problem solving in statics. Alright, if you even have problem with how it is, not how it is applied, but how it works, sine, cosine for example, then please do refresh from whatever you have learned before. Discuss with your friends, etc., because you really need this foundation to then apply and then solve the statics problem. Alright, without further ado, so first thing in this part is on the trigonometry. We have basically sine, cosine, and tangent, right? Hopefully you can see this. I'm not sure, should I write it bigger? But anyway, I think you know the concept where basically if you have any angle, right, let's say theta, it can be described in with this one. If you have, for example, if you imagine it to be a triangle with a right angle there, then if you have, let's say, A, B, C, then you have sine theta is opposite over hypotenuse, so B over B over C, and cosine of theta is adjacent over hypotenuse, so A over C. Then tangent theta is opposite over adjacent, right, B over A in this particular case, right? You have learned this before, and some memorize it as like so. Right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over hypotenuse. So this is the basic things, right? So I'm not really teaching you this. I'm just refreshing this because this will be what we normally use and apply, and it just should be a split second calculation. It's not even a calculation. You should know already how to convert it. For example, when we have a certain force there, right? And then it can be, it is actually made up of two components, which is the horizontal and vertical component. Of course, in this case, vertical is going down. So we can say this is fx and fy, which is the component of f, right? Meaning that the resultant of these two becomes this one, right? So if we have this theta, right, you should be able to split in split second. You already know that fx is f cos theta and fy f sine theta. Now, for those who have no problem whatsoever with this one, then alhamdulillah, for this part you are good to go, right? My problem is if some of you still struggle, how is this become f sine theta? How does this become f cos theta? It actually comes from here, right? For example, if in this case, hopefully you can see the parallel where we can see that this is f right? If this is f, and this will be basically fx, and this will be fy, right? This component and this component become this resultant, right? So if you can imagine that one, and you know how to get this one, so basically f is basically c here, right? This is f, right? And fx is a, right? fx, and fy is b, fy, right? So from here, we can rearrange, right? Because here you basically, from here, basically sine theta is fy over f. Basically, if you rearrange this, f sine theta equal to fy, right? Should be the same here, right? From this one, cos theta equal to fx over f. So if you rearrange f cos theta equal to fx, so fx is f cos theta. So these are the very fundamental thing that you should have it at your fingertip. Literally, not literally, but really at your fingertip. Because just looking at it, you know this is f cos theta, f sin theta, if theta is here, right? If, for example, let's use a different color, we have alpha here. Another, can you see? Hopefully it's not glaring. So if you have alpha here, now if you want to make it in relation with this one, this will be f cos alpha, this one will be f sine alpha, right? Because cos is adjacent, sine is opposite, right? So that's the first thing, and this should not be a problem for any first year student taking engineering, because we just need to apply this one. This is nothing new. This is just something that you already need to be able to apply straight away. So up till this point, I do expect no one is having any trouble yet. I expect everyone will have just nodding and okay, we understand this, right? Hopefully. But if any of you struggle to understand any of this, before second week of lecture, make sure, go about it, do whatever you need to understand this, because you really need, because if you have problem with this one, that 14 weeks of statics will not be something that you can go through and pass, right? So this is very, very fundamental. Now we are still dealing with two-dimensional here, right? And yeah, before we go to three-dimensional, there's another way angle can be described in statics problem or in any problem in that case. For example, it can be described in this way. We have f, and then we have the triangle. Like let's say 3, 4, 5. Right, can you see this? I hope you can see this because there's some lighting and there's some reflection here. But I'm sorry with this lighting, but this is the available class and hopefully you can still see. Alright, now in this case, what will be the x component and the y component? Now, this is the thing. Some of the students, they will turn this triangle into angle first, into whatever angle first, right? But two things. One, that can create an error, because when you convert into an angle, whatever, this is 3, 4, 5 or 5, 12, is it 5, 12, 13 or whatever angle that is, or triangle, when you calculate the angle, it will have some decimal points, and you tend to round off, and that is where you introduce some error. And when you multiply in your calculation, the error can become big and significant. So that is a problem, number one. Number two, it's actually much easier to straight away use this value than convert it and then calculate, right? So why do you do the difficult things just because you don't understand? Make sure you understand, and it will become easy. Now, for those who can see straight away, you'll know straight away, right? This one, fx, it will become f 4 over 5. This will become f 3 over 5. just by looking at this triangle. Now, for those who have no problem and you can straight away come to this, Alhamdulillah, for 2D, you have no problem in terms of resolving force. But if you start to have what, how come, why, then make sure you go about it, train yourself so that you understand, oh, okay, that's how, that's why, right? Now, with this triangle, basically, the concept is just if you have the similar triangle concept, right? Meaning that if you have a small triangle, let's say in this case like this, right? And a bigger triangle, can you see this? Okay. And a bigger triangle, meaning that with this is our right angle, and then basically this angle is the same, right? This angle is the same. If this angle is the same for this smaller triangle and the bigger triangle, meaning sine of this angle is the same, right? Meaning this is just theoretically first. Right? Some students do not need to understand the theory. You just memorize and apply, right? But I do like to touch a bit on the theory, because if you understand, even if you forget, you can still derive it back again, right? So like sine theta will always be sine theta, right? Even if it is for the small triangle or the bigger triangle, because this is still theta, this is still theta. What this means is this ratio, sine is opposite over hypotenuse, and opposite hypotenuse will be the same. Meaning the ratio, right? The answer of this over this should be the same. Meaning the ratio of all of this, it will be the same, right? For example, in this case, if you look at the small triangle, this small triangle, this is 3, 4, 5, right? That's the small triangle. 3, 4, 5, 3, 4, 5. The big triangle, this one is what? This one is F, right? And then this is Fx, and then this is Fy, right? So by ratio, right? For example, sine theta is 3 over 5, right? 3 over 5 should be the same ratio as sine theta is Fy over F. Correct? Meaning that opposite of hypotenuse should be the same as opposite hypotenuse, because both are sine. Right? So from here, if you rearrange, you will get, if you bring it here, F 3 over 5 equal to Fy, which is this one. Fy equal to F times 3 over 5. Same case with cosine. Cosine is adjacent over hypotenuse, which is 4 over 5 equal to adjacent over hypotenuse, Fx over F. If you rearrange this one, F times 4 over 5 equal to Fx. So Fx is 4, F times 4 over 5. So with this ratio, the calculation is just split second. You just looking at this. This one is F times 3 over 5. This one is F times 4 over 5. It doesn't take you any minute, and you do not introduce any error, right? It's actually the original value, right? So that is important, and that is the basic for 2D. Hopefully until now you still can follow. Anyone who have started to struggle at any point, please discuss with your friend. If you and your friend cannot resolve it, you can come to see me and discuss if anything not clear. But also, please on your own also try to, if you find any difficulty, go back to your notebook, your textbook from your CFS or school, or even there's a lot of tutorial online. There's no excuse not to find any sources. There are a lot of this. This is very basic. Okay, that's 2D. Right? What about 3D? Now, in our subject, we actually learn to solve for 2-dimensional and also 3-dimensional. The 2-dimensional is the basic one. It's just normally for us to familiarize with the concept before we go to actually the 3D. Because in the reality, objects are 3D. Right? We have to understand how to solve for 3-dimensional object. Right? So, if this is no problem, and you have this already at your fingertip, then it is okay. It should be okay thing for you to go for 3D. If you have a problem with 2D, 3D will be more complicated because you cannot even visualize, or if you can visualize, you cannot even calculate. At your fingertip, of course. When I say at your fingertip, because statics or mechanical engineering subjects should not test you on this. This is just like how you know how to use your calculator, right? It's not a new concept. It's not anything that you are tested on. It's just we expect you already to know how to use it, and the test comes from the new things that you learn, and anything that you learn in statics specifically, to solve it, you have to use all of these tools, and that's why no one will teach this, because that's the requirement for entry before you can go into engineering subject. This one you have been tested before, right? But I'm not sure why some students have, maybe after exam they reboot the brain, right? They set Control A, delete, empty the recycle bin or whatever, so they forget everything. I'm not sure if that's the case. Hopefully not for you. All right. What about 3D? Right. So if you imagine this, for example, right, where you have x-axis, y-axis, and z-axis. So hopefully you can understand this drawing in 3D, right? So like x-axis, y-axis, and z-axis, right? It's a 3D space. So let's imagine if we have, let's imagine like this. Oops. So something like this, right? F here, right? Okay. So this means it's like, do we need to put a value? Perhaps let it become complicated. Okay, I'll put some value, right? If we say, okay, let's have this to be, what is logical here? Let's have this to be 45 degrees, and let this be going down at 60 degrees, right? Is it clear from this drawing? So what this means is, if you can imagine, x, y, z, right? Like x, y, and z. So this means that from x, y, right? Okay, let's make here like this. This means that it is 45 degrees from y, meaning that in this plane of x, y, in this plane, so from y here it goes 45 degrees there, right? In the middle of this, it goes 45 degrees here. And then from there it goes 60 degrees down, meaning 60 degrees downwards. So F is there. I cannot show the whole thing, but it's going there, right? Meaning it goes X, Y, Z. So 45 degrees in this plane, and then going down 60 degrees. That is what it means by this drawing, right? That's the first thing. I think it's key that you can visualize and understand what this means. It goes 45 degrees here, going 60 degrees down. That's where that F is, that force. Alright. How to deal with this one? Because it will basically have, let's use this color. What this means is it will have Fx component. This is X component here. You have Fy here is the Y component, and you have, right? Wait. How is this how to imagine this? Okay, let's say like this, right? Fz. Right? Meaning it will have X component, Y component, Z component, and in this case Z component is going down, which is negative direction, to make this resultant force. Right? This is the resultant is X, Y, Z component. Now, so we need to be able to determine what is this component. Just like before, when we have F, you have x component, y component. In this case, 3D, you have x, y, z component. How to get this? From this is the only information given, right? 45 degrees, 60 degrees. So if you cannot even imagine what is going on in the 3D space, that's one problem. Make sure you can imagine, just see and imagine, right? That's number one. Number two, even if you can imagine, if you cannot relate to the sine, cosine, or whatever, the triangles, I don't want to say anything, but you need to be able to relate those things. Otherwise, there's no way to compute it. You will be stuck here, even though okay, this is just mathematics. This is not statics. That's why I'm making this video separate. This is something that you need to be able to do and use it for statics, right? So in this course, it teaches you statics. You should know this already, right? But some students struggle with this one. That's why this one is to help a bit. Hopefully it does help. Now, the thing that you should be able to do is you have to be able to visualize the two triangles, right? Let's say one triangle is, what color do I have to use? Let's just use black one. Okay, let's consider this as one triangle. Okay, my drawing might be somewhat off in the angle, but hopefully you can still imagine, right? Meaning that in this x, y, it is in the middle here, this triangle here, meaning here, that triangle there, right? Just this one. Hopefully you can imagine that the right angle is here. The 90 degrees is there, right? Maybe my drawing is a bit off, but because when you see x, y, z, x, y, z, this one, the right angle is here, right? With the axis here. Hopefully you can. So this one going here, that's the right angle, right? Now, that's one triangle, and if you look from above, it will look something like this, right? Because if you look from above, the axis, right? If you look from above, if you can imagine, x-axis is here, y-axis is here, right? Imagine if you look from above, y is here, x is going down because this is a right angle, right? If you look from above. So this triangle is making 45 degrees here, right? And this is where the right angle is, which is this one, right? So that's crucial for you to be able to visualize. Okay, if you imagine looking from up, okay, because this is the square, right? Not square, rectangle, right? Okay, that's number one. And you can straight away relate that this is Fy, right? This is Fy. Okay, and this one is this one. Because it doesn't have any name in the original one, we just label it like, what's the easiest? Normally they use like F prime, just to differentiate with F. Let's just use it, right? So this is F prime here. Okay, F prime. Is it clear there? Make it more clear, so there is no confusion with F. That's F prime. And then there's another triangle, which is this one. Right? Where the right angle is here. Because if you understand from the beginning, we go here and then going down. This is a triangle. So this make a triangle, right? Down, up, meaning here, right here, to this force, right? So this is the right angle here. If you can imagine, right? It goes like this and going down. So that one makes the triangle there, right? So if you imagine looking from here, basically you imagine looking perpendicular from the plane of the triangle, so it will look something like this, right? If you look from here, this is the right angle, and you can see that this hypotenuse here is this F here, right? Hypotenuse here is this F. What is this one? is this one, which is f prime just now. And what is this one? Is basically this one. Right? Basically is the z component. This is f z. Obviously downwards. Alright? So first thing first, before you start calculating, for those who have never done this one or have some problem, visualize, make sure you can imagine the two triangles, one triangle and two triangles, and then you can draw it like this, right? When you can imagine this one, then you can apply the 2D that you have understood, right? Then it's become easier. Now, this 60 degrees is where? It's here, right? 60 degrees. Alright, so with this, when you have the two triangles and you already have the angles, and you have already F here, okay, what is this one? Something is missing here. This one is this, right? What is it? This one is basically this one, right? It is Fx. Yeah. So Fx, which is the same as here, Fy, or this one, Fz, Fz. Right? Now, from here you can relate. Right? From the understanding, is it enough space? So from here, this is F, this is 60 degrees, so Fz here is F sine 60 degrees. Is it in the frame? It's still in the frame. Right? So opposite hypotenuse, right? So Fz here is F sine 60, F prime here is F cos 60. Right? Any problem here? Hopefully not. This is exactly what we have covered for the two-dimensional before. When you have an angle, so when you have F, so this is F sine theta, F cos theta, from the understanding of sine, cosine. Tangent is not involved here, unfortunately. Unfortunately for tangent. Okay, so this one, what is this one? So Fx is, when this is F prime, this is F prime sine theta. Not theta, sorry, 45. This is 45 degrees, so 45 degrees. This is F prime cos 45 degrees. Yeah. From there, you already have make the relationship between each of these three sides of the triangles, both triangles. Right. So how to resolve this? Okay, now we know already F prime is this one, right? F prime is this whole thing inside. You can just substitute this into this one, right? To F prime. To F prime, right? Meaning F prime equal to this one, so you can just plug in. So in this case, Fx becomes, you plug in this whole thing into F prime, becomes F cos 60, which is this whole thing. You replace F prime, and then just continue with this one, becomes sine 45. Is it still in the frame? Hopefully. Alright. In this case, you just replace this inside here, so Fy becomes F cos 60, then cos 45 degrees. Hence, you can come to the conclusion that, alright, so this is Fx is F cos 60 sine 45. Fy is F cos 60 cos 45. Fz is F sine 60. So you have the three component, right? So this is how we deal with this triangle. Now this does take some time when you want to calculate, but it shouldn't be that long, because right now we do take some time because I'm explaining. But when you do, now the thing is, some who have done this before, they can calculate it straight away, right? Just looking at this, because what they do is like this. Because let's say x, y, z, right? And if this is something here, they say, okay, to get x, this cos this angle, sine this angle becomes here, right? And then cos, right? Sine, right? So they can already imagine what this angle effect, right, in terms of sine and cosine. So if you have done enough exercises, that can become naturally for you. So you don't really take that much time. It's less than 1 minute to get the 3, right? But if you need to, do not assume, do not gamble, do step by step. Do the triangle, visualize, do the triangle, write everything, and then you can get the correct one, fx, fy, and fz. Spend a little bit more time, especially if you haven't done any exercise on this. That is necessary, because once you have done for 5-6 times, then you can do it in your head, and even without drawing on paper, you can get this one, because you can imagine all of this in your head, right? But if you haven't done yet, please do it on paper first, because that will train your head to visualize it correctly. Alright, so these are what I want to share. These are basic things. This has nothing to do with mechanics statics. This has everything to do with mathematics. Just that normally in static we do need every of this component, right? Because we have to express everything in Cartesian vector form, for example. So it does require the x component, y component, and z component, and from there only you can calculate using vector operation or whatever we will be learning in statics, right? So the issue for, I think the crucial issue here is that if this mathematics you struggle with, even if you understand everything in mechanics, you cannot apply, or your answer will be wrong still, because it's just like when you understand but you do not know how to use your calculator correctly, you get wrong answer, unfortunately, and that will affect your mark, and we do not want that. So make sure you know how to use your calculator correctly, and you know how to use basic trigonometry correctly. Alright, so that's for the first part. Before we go to the integration, I'll end the recording and begin a new one. Hopefully it helped in refreshing all of this. And again, make sure you understand this before the second week. That's the most ideal scenario. If not, as soon as possible. The second week is the latest, I think, because after that we already have week after week after week. Each week we have new things that you have to understand, and then straightway you have to apply all of this in solving. I'm not trying to scare anyone. I'm just saying how seriously I want all of you not to have a problem in this subject, and that's why this is important. Alright, all the best, inshallah. Bismillah. And any question, you can ask me in the class. That's the best that's the best I think, or even here, just if you have anything that you think I should take note of and you don't understand, or my explanation is not clear enough, etc., you can also comment. Let me know, inshallah. Alright, so we'll move on to the next one for integration, inshallah. See you in that one.